Hello. Actually, I have to, again, I am doing it second time. Actually, there was a technical issue in the first time, so I have already solved it, as you can see it. So I will explain here itself. I will not. I am not solving once again. So, but I will explain step by step so that you can understand. So, okay, question number 13. What was asked that for the matrix P, one of the eigenvalues is equal to -2. Which of the following is the eigenvector? So this is P given. This is mu lambda is given. Your -2. So what is asked? To find the eigenvector. We know the formula for eigenvector is A into X is equal to lambda into X, where X is your eigenvector. So you can, if you choose the options, then it will be problematic for you because it will time taking, because A, then you have to take 1 X and you have to multiply with A, and every time here also you have to multiply, here also you have to multiply, and you have to check. So better calculate eigenvectors. How to calculate eigenvector? This is the basic equation. If you take it this side, it becomes this. So from here, this is your eigenvector. So it is A minus lambda, means here you, from here you will minus lambda from diagonals. Only from diagonals lambda will be deducted. 3 minus -2 plus 5 -2 0, 1 minus -2 3. All remain same. So it becomes again x1 x2 x3 and then 0 0 0. Okay. So now in order to get this vector or solutions of this one, that same method you can use the canonical form method, that is also used for solving simultaneous equations. So what we will do, this is 1, okay, 1, it is not mandatory, it's 0 0. Then next one is here, okay, good. So this one should not be 1, because the next one should be left to the upper one. So this one should be 0. So how to make it 0? So you use this one, R3 is replaced by R3 minus 3 into R2. So if you do this one, so what will happen? 5, this everything will remain same. This is 0 0 0 and this is 0. So if you write the equation, it is 5x1 minus 2x2 plus 3x3 is equal to 0, and from here 0 0 and x3 is equal to 0. The equations I am writing, the first equation is this one, 5x1 minus 2x2 plus 2x3 equal to 0. Then from this one, so now x3 is already given 0, so it will be 5x1 minus 2x2 equal to 0. So now you can see here it is a 3 unknown, and the number of rows you can see 2. Unknown is 3. So rank is 2 here. So it will be infinite solution. So for infinite solution you have to assume something, because you are left with only one equation, 5x1 minus 2x2 equal to 0, because x3 equal to 0. So what to proceed? So you have to go for, because you are having one short, rank is 2, one equation has been nullified. So you have 5x1 minus 2, so you have to take 1x. So 1 you have to assume. So x2 equal to k, so therefore x1 equal to this. So it is x1. Now what is your eigenvector? This is your eigenvector x1, x2, x3. So it is 2 by 5 k, then it is k, then it is 0. If you take k common, it is 2 by 5, 1 0, and if you take then 1 by 5 common, 2 5 0. Because the vector is required. Anything you can take common, anything you can multiply. That scalar value doesn't matter. You need to just find what is the vector. That is, they have eigenvector means only vector. You can multiply it, you can divide it by anything. Linear multiplication, that scalar multiplication will not come here. Okay, so it is 2 5 0. Then next is now you can recall this question with question number 3. That's why I have written here question number 3. Question number 3, if you go to question number 3, you will find that there also I have discussed a homogeneous equation, and while infinite solution that was also rank 2 less than 3. You can recall that question number 3. So I have taken one example. I have told you that in that case, if your rank is here, if you say you have 2 equation, 3 unknown, rank is 2, so you have to assume something k, then you have to express x1 x2 in terms of that one. So here also you have done this one. So this is the way to calculate infinite solutions. How to calculate, how we will find infinite solution. So next is 14. 14 is given x is equal to some vector x1 x2 x3 n, and then v is equal to also given x, and it is given n tuple. Non-tuple is nothing but it is a data structure, the way they write. It is nothing but vector. Don't get confused with these heavy words if you are not familiar with. So this is your x1 x, and what is v? V is equal to this x, transpose means this one, multiplied by transpose of this one, then again this one. So if you multiply it, v becomes something like that, x1 into x1, x1 square, x1 x2, x1 x3, last is x1 xn, same is x2 x1, x2 square. So you can do it up to this much. Now as your matrix becomes so big, Now, how to analyze this one? How to find rank of this one? So this is a particular type of questions which is known as general questions. General questions means these questions are true for all value of n, because they have not mentioned any value of n. They have specified up to n. This is so. If you take n3 also, this should satisfy. If you should n4 also, this should satisfy. This type of questions is known as general questions. So while dealing this type of questions, you can take any value of n you desire to start with, so that it becomes simple or smaller for you to analyze. Then you can think, if for n equal to 2, whether it will be true for n equal to 3 for higher values. If it is true, then that is the common answer, general answer. So the better way to visualize or to solve this type of general questions in any topic, if you find the general questions where if you feel that for any value of n it will be true, the questioner, the examiner who I asked the question, he wants the question to be true for all value of n. So in that case, you can take any value of n. So we have taken n equal to 2. Now if you would n equal to 2, what it will become? It will become x1 square, x1, x2, x2, x1, then x2 square. Up to this much will be. So it is this much. So in the options, there are something they told about rank. Orthogonal means if a matrix is orthogonal, option B is there. A into A transpose equal to I. If it is orthogonal, then it should satisfy. So orthogonal we will check later. Let us try first to find rank. If we can find rank, then our answer is there. So for rank, what we will make? We will make it canonical form. So this one we will make 1. So to make this one 1, we will divide R1 by x1 square. So it will be x1 square by x1 square 1. This divided by x1 square, x1 cancel, x2 by x1. This remains same. Now next is this one to be 0. So how to make this one to be 0? R2 minus x2 x1 multiplied by R1. If you make this one, so this is this. Now you can feel, now if you are writing x2 by x1, you can feel what will be the next one. What will be the next one? x3 by x1. What will be here? x2 x3. If it would have been 3 cross 3, or if you would write it up to n, so it should be something like that. You should keep it in back of your mind that we are taking 2, okay, correct, but it is up to n, so that you can generalize the answer. So if you are doing this one, you will find these two are 0. So you think about that, you are getting that third one will also be 0, because it is x3 by x1. You can see if you multiplied by x1 x2, x1 x2, so x1 cancel, so it is x2 x3, so x2 x3 minus x2 x3 will be 0. So the entire row will be coming 0. So similarly, your next row will be also 0. Next row, you can feel it now. Okay, it is general approach, it is coming 0. Okay, that's why only one number of non-zero row is 1, therefore rank is 1. So the answer is this. So again, I am telling this type of question are very important type of approach you need. These are specific approach which are known as general type approach. You can reduce the value by taking n as per your convenience, but you have to always think that it is a question of n. You should not be happy with 2. You are solving this one, you are getting answer 1, okay, correct. No, you should check with 3 also n equal to. If you are not solving, you have to think it in mind also, okay, whether we are getting it or correct. If you are satisfying with n equal to 2 answer, we are giving answer, in some case it may wrong also. So you have to think whether it will be 2 or 3 or 4 or something like that. Next, coming to question number 15, they have mentioned this symbol. This symbol they have seen as a dot product. Whatever the symbol they give, you know that product is xy dot product, x, y, cos theta. Theta is the angle between the vectors. So if you take x dot, it will be x square, because theta is 0, cos 0 is 1. That is xy dot, y dot. If you take determinant, you can find xy square minus this into this. If you take common, it is 1 minus cos square, it is sin square. Now there are some options. Specific, these are again, they are playing with the options or playing with the words. So you have to be very careful while choosing the options, because these are not specific. You are not getting any answer 2, 3, 4 that the answer is 2. You are getting answer 2. It is correct. These are statement type questions. You have to understand the statement. What is the statement saying? So there are A, B are depending and independent. They are talking about linearly dependent, linear. So let us forget this. Let us try the easiest one in the that is C and D. These are easy to explain, or it is easy to understand also. C is non-zero for all non-zero x and y. What is they saying? Is non-zero for all non-zero x and y. Means x and y are non-zero, they are given. Now they are saying the answer will be always non-zero. Whether it is true? No. Because if these two are non-zero, suppose 2 and 3, still it can be 0. Still delta can be 0. How? Because if your theta is 0, then your delta will be 0, sin 0 is 0. So that's why C is not correct. Next we go for D. Is 0 only when? You focus on the word only. They are saying only when. only when x and y are 0. If x or y are 0, then only it is 0. Other case it will not be 0, they are saying. But we know there is other case. If theta is 0, then also it is 0. X and y, they are non-zero. But theta is 0, then it is 0. So they are saying only for this one it is 0, which is not true. This is also 0 for theta equal to 0. So again, this is not true. You focus on the word only. Now you go for A. Now we are saying that x and y are linearly independent. Again, we have studied what is independent equation, linearly independent equation. Suppose this is the equation x1, x2 equal to. If you multiply it by 2 and you give it to me, sir, we have two equations, solve it. So effectively you are giving me only one equation. This is nothing but this is depending on this. This is known as dependency. Just a linear product. In vector also, this is a linear product or linear combination. So vector, it is simply linear product. A vector is a linear product. If you are multiplying with a scalar, then these two vectors are known as linearly dependent. Not independent. They are linearly dependent. These are dependent. They are not independent equations. You have not given me two equations. You have given me one equation. This equation is depending on this, which is not an independent equation. So this is linearly dependent. That means two vectors are parallel. If it is just multiplying with scalar, direction remains same. So these two vectors are parallel vectors. These two are x and y. And then theta is 0 if parallel vector is. So linearly dependent means they are saying parallel. Parallel means they are saying theta equal to 0. So this is the main one thing they have given in option A. So they are saying linearly independent. So these two are not equal. That means this is not parallel. That means this is not 0. So theta is not equal to 0. Okay. So they have given is 0 when it is linearly independent. It will be 0 when they are linearly independent. Linearly independent means this one. They are saying if delta is not equal to 0, then it is 0, which is not true. If delta is not equal to 0, then it depends on x and y. If delta is not equal to 0, sin theta is not, that is good. But it is not sin theta. In delta you have x square, y square also. So it also depends on x and y. So again, this is not true. So that last option that remains with us, obviously it will be correct. You can check also. Is positive when x and y are linearly independent. Linearly independent, again that means theta is not equal to 0, which is good. And it is positive. Okay, it is positive because theta is not equal to 0. So this will be positive, this will be positive. It will never be negative because every time it is square. Whole square, whole square, whole square. So this is the correct answer. Next we go for the last one for today, that is 16. They have given one vector, linear operation Lx defined by the cross product. Cross product, you know, this is a vector they have given B. Transpose in transpose format they have given. So I make it in original format 0, 1, 0. So what does vector represents in matrix? It is simple. Suppose if I write a vector 2, 3, 4, what does this represent in vector? It is represent 2i, 3j, 4k. That's all. We are writing vectors in matrix format. That's it. So what is cross product? I know I, j, k. Then first you can remember a1, a2, a3, b1, b2, b3, I, j, k. That is the cross product in vector. So if you do the cross product, you can find the determinant I into this minus this into this minus j into this will be 0 plus k into this minus this into this. So ultimately you will get this one. So if you write it in vector format, the I will come first because 2 is first, 3 is second, k is 4, I, j, k, I, x3, j is not there 0, k is not there minus. So this is your L. This much we got. Now what they have given, now they are saying that L is equal to some m multiplied by x. Okay, some m multiplied, m is 3 cross, so this is unknown. You don't know anything till now. I have already solved it, that's why it is there. Now we'll fix it. So it is x1, x2, x3 and this is x3. So what should be there? It should be something like that. If you product it, it should come x3. So if you put 0, 0, then it is 1. So 1 into x3, x3, our x2 will be 0. So it is x3. Next one is 0, so everything 0 plus 0 plus 0. Next one is x1, so minus x1 plus 0 plus 0. So this is your m. Once you got m, now they have asked you to find the eigenvalues. So I thought, let us check with the, why not? Because it is very easy to sum, what will be the sum of these eigenvalues? Because the trace is 0 plus 0 plus 0, 0. So why not check whether the sum is 0 or not? If I am very lucky, so I will get the answer without solving eigenvalue. So option A, if you add it, then it is 0. Option B, if you add it, it is not 0, it is 1. So it is not the answer. Option C, again it is 1, it is not the answer. Option D, it is 0. So A and D, either one can be. Then I thought of calculating product. Product is also easy. Product of eigenvalue, determinant. If you say that, what will be the determinant? Because this row is 0. This row is 0 means any row 0, determinant will be 0. So again you see, if you take product of all three, 0 into 1 into minus 1, 0. So A is okay. B and C is already gone. D is also okay, 0. So we are not lucky enough. We have to solve the eigenvalue. So next we are solving it. So how to solve eigenvalue? Eigenvalue is A minus lambda I. We have already solved equal to 0. So you deduct lambda from these. All the diagonals you will deduct lambda. That's it. Minus lambda, 0 minus lambda, 0 minus lambda, 0 minus lambda. So if you take determinant of this, you can find minus lambda this, minus 0 plus 1 into this. I think you can find it. If you do it, if you take lambda common, then it is, sorry. If you take minus, it is lambda plus lambda. No? If you take lambda common, then it is lambda square plus 1. So it either lambda equal to 0 or lambda equal to plus minus I. That is your option D is the correct, not A. Correct it, modify it. So it is D is the correct answer, because I have taken a sign notation. Cross check it. This and this is alpha square, okay. Minus alpha cube, this is okay, 0, this is plus 1, 0, minus, and minus 1 is plus alpha. So minus alpha cube, minus alpha square. Done. So this is okay. So that's all for today. I have already given the link of this in the description to download the questions that I have written in the Word file. So you can find the download link in the description. When download it, it will be helpful for you to solve it.